Okay, this will be our last lecture on section 3.5. This is a your turn example. So I want you to pause your monitor and grab these two examples, work them on your own, and then come back, unpause, and see how you did. Okay, working example number 5. The first thing I want to do is I want to read the problem. So I'm going to give a linear equation to describe the scenario. It says every month the value of my stock portfolio increases by $1.50. Oh, that tells me I'm doing this per this. Oh my gosh, well that must be rate of change. So that's my rate of change. So I'm going to write that down as such, right? And so that's 150. And I'm not going to use my units because I already have them written here. Then it goes on to say, when I invested my money, I put $250 into my account. Well, when I start, that's another way of saying baseline, right? The start. When the amount of independent was 0, the dependent was this. Well, 0 is in months, right? 0 months, that's when I started. So the baseline, the start here, is going to be 250. And we see that the 250 is, of course, in the units of the dependent variable that we see in the numerator of our rate of change. Now we just need to define our dependent and our independent variables, and we'll be ready to write a model. So the dependent is the total dollars in this fund. So in the stock portfolio, I'll call that S period, P period to save me time and energy. And then after, and it's some number of months. So I'll call that N months. And I'll put quotation marks around the end so that it doesn't get lost in there. And so that is my dependent. And I'm going to call that D for dollars, and I'm going to use capital D. And then I'm going to go for my independent values. Okay, my independent values, well, that we see down here in the denominator of the rate of change. That's the number of months. So the number of months. And the number of months is equal to N. That's what I'm going to call my independent value. And so now I'm going to write my model. My dependent value, the total dollar in the stock portfolio after N months, is equal to my baseline, which I started with 250, plus the rate of change, $1.50 per month, times those number of months. And there I go. There's my model. And so my value of my stock portfolio starts out at $250 when I first put it in, N equals 0, and it increases by $1.50 each time. All right, moving on to example number 6. The first thing that we want to do is we want to investigate and see if this is a linear function. So my x's, my change in x's, I'll use that triangle to do the change in x's, and then the changes in y's, and we want to see constant in each case. So 6 to 12 goes up by 6, 12 to 18 goes up by 6, 8 to 15, that goes up by 7. 15 to 22, that goes up by 7. So these are looking linear. Remember, this shows us our rate of change, right? The dependent over the independent, that's our rate of change, also known as your slope. And so that's our slope. Now we just need the y-intercept. So remember, not only can we move forward this way, we can also move backward this way. So 18 minus 6 is 12, and 12 minus 6 is 6. And so let's go one more, 6 minus 6, which is equal to 0. And then let's do the y's the same way. 22 minus 7 is 15. 15 minus 7 is 8. And so 8 minus 7 is 1. And now we know the y-intercept. And so now I can make my model. And my model is going to look like y is equal to my slope, 7, 6, times my independent, plus my y-intercept. And there we go. There's our model.